All right, so how are we doing? So here we go. We just got part one done. Here's our free body diagram. I'm going to remove that. Now the second part is to figure out the force of friction. We want to know what this force is, the force of friction. Well, since it's not moving, the idea here is to sum up all the forces to the left and all the forces to the right. So let's just do that. Right, so basically, let me keep this in here. Let's come back to this. Let's make this thin. Come on. Make this thin, and let's change colors a little bit. We'll go to blue. All right, so always think we're going to do is we're going to do sum of the forces in the x direction, right? All the forces sideways. Now, picture's in the way there. Look at that. All right, so what forces are to the left? It's not moving. So we know the sum of the forces is 0. The forces to the right are canceled by the forces to the left because it's at rest. At rest is one of the scenarios for equilibrium. All right, so let's see. Generally, everything to the right, the sum of the forces in the x direction, part of that 20 newtons is to the right. Remember, this is at an angle of 30 degrees. That is 30 degrees there. So if we were to say like alternate interior angles cut by a bisector, that angle is 30, that angle is 30. So now how much of that 20 Newton at that angle is sideways? Not all of it's not 20 sides. So the adjacent part of that, if we were to have this here at 30 degrees, and we were to want to know just what's the sideways piece, okay, just how much of that is sideways. Well, if this is our 30-degree angle, this is the adjacent side to 30 degrees. So going back to trigonometry, we're going to use cosine. So the piece of this is going to be 20 newtons times the cosine of 30 degrees. The cosine of 30 degrees is 0.8666, whatever it is. And then you multiply that by 20, we're going to come up with something about 17.3. Okay, so that piece, so we're going to get the force applied in the x direction minus the force of friction. All of those things are going to equal 0. So this is going to be 17.3 newtons minus the force of friction equals 0. It's only those two forces acting horizontally. So that equals the sum of the forces in the x direction. Well, that tells you if you do this, bring the force of friction over there, 17.3 newtons equals the force of friction. So we were able to figure out the force of friction is 17.3 newtons, which is the answer to the question.